this hour is y is equal to the square root of x plus the square root of x. Okay. And the way I said that and the way that I wrote that, the way I said it might have been pretty ambiguous. So we've got the square root of everything else, and the everything else is x plus the square root of x. All right, now our goal is to calculate the derivative of this function. And remember, all of this derivative stuff, right now we're literally into the nuts and bolts of calculating derivatives. So in terms of why we're going to use this, we're really not focused on that too much at all right now. But it's a totally legitimate question to ask about, but we won't be talking about it today, unfortunately. Okay, so here's our function. And so the very, very, very first thing I want to do is, as soon as I see a square root, I want to rewrite that as a power. So I've got x plus x to the 1/2, all of that raised to the 1/2. And so what I see here now is that I see that I have, just sort of looking at this, I've got a big set of parentheses hugging an inside part of this function. And so the second that I see this complexity, this nestedness of my functions, I want to think, I'm going to need to apply the chain rule. And so when I apply the chain rule, I want to identify which is my inside function and which is my outside function. And in this case, the inside function is going to be the x plus x to the 1/2. And the outside function is stuff raised to the 1/2. So our outside function is x to the 1/2. All right, are there any questions on identifying the inside and the outside function? Okay. So part of my side work here is that I'm going to need to take the derivative of the inside portion. So derivative of the inside is going to be 1 plus 1/2 x to the negative 1/2. And the derivative of my outside function will be 1/2 x to the negative 1/2. One thing that you'll notice that I'm doing here is when I start, for example, with my inside function, and I take its derivative to get this new expression, 1 plus 1/2 x to the negative 1/2, I am nowhere am I writing an equal sign, because the original function and its derivative are not equal functions. I'm writing an arrow saying, hey, I'm taking the derivative to get this new function. Okay, so our derivative looks like y prime, which is going to be derivative of the outside, keeping the inside the same. So here's my outside function. 1/2, keeping the inside the same. Everywhere I see an x, I'm going to replace it with x plus x to the 1/2. So derivative of the outside, keeping the inside the same, looks like 1/2 times the quantity x plus x to the 1/2, all raised to the negative 1/2. Derivative of the outside, keeping the inside the same, times the derivative of the inside. So times 1 plus 1/2 x to the negative 1/2. And this is my derivative. All right, any questions about that? Oh, you're just stretching. Okay. All right.